Measuring fish behaviour and growth, as well as seaweed growth in response to stresses and disease, can help obtain insights into how we can make fish and seaweed farming more efficient. Here at Sonardyne, we've been working with SINTEF Sealab on a project called BEDLAM, which has been funded by the Aqua XL 3.0 Transnational Access Programme. This programme allowed us to deploy our Origin 600 ADCP at 2 sites based off the island of Hitra in Norway, the Skavoya seaweed farm and the Slingsholmen salmon farm. Being able to enhance monitoring at aquaculture sites in terms of both traditional post-processing analyses but also near real-time monitoring is highly valuable. As such, both deployments aim to leverage new capabilities provided by the Origin 600 ADCP that can benefit critical markets such as aquaculture and carbon sequestration. We collected data on currents and waves, as well as backscatter intensity data to track growth rates with high spatial resolution. This high spatial resolution provides the ability to monitor changes in fish behaviour, such as clustering, on spatial scales that are better matched to individual fish. The data we gathered allowed us to monitor fish growth and behaviour in the pen, as well as helping us determine the growth rates of seaweed, both of which can be affected by nutrients in the water, diseases, and by currents and waves. This is information that can be used to help optimise operations at the site, leading to better yields, and thanks to Origin's onboard edge processing and integrated acoustic connectivity, we can deliver this information to the surface and into the cloud in real time, providing SINTEF with a live feed of the subsea environment.
Both projects also aimed to enhance the utility and value of post-processing data analyses to drive efficiency improvements within aquaculture and associated with carbon sequestration by seaweed cultivation. Using our Edge Waves app, we extracted information about the mean currents and wave activity throughout both deployments, allowing us to measure the impact of changing environmental conditions on the aquaculture sites.
At the seaweed site, one of the ADCP beams was positioned to intersect the growing kelp, so we were able to use the backscatter intensity data to provide estimates of the position and physical length of the seaweed as a function of time. The velocity and backscatter intensity results showed that even in relatively quiescent wave conditions, the influence of waves was felt significantly below the water surface. In the fish farm, we were able to detect bulk motions of the fish on minute-long and day-long timescales, corresponding to motion within the pen and the tidal cycle respectively. While this analysis was performed after the ADCPs were retrieved, in the future these algorithms could be used to produce results in situ.
The TNA programme has been a great experience, providing us access to the 2 sites and some really challenging conditions for designing our measurement campaign. It's also allowed us to trial some new features on Origin 600, which we hope will be useful additions to our product. More information on that soon.
SINTEF has been a pleasure to work with from the beginning. Their staff have been really helpful, knowledgeable and supportive, and we've worked hard together to give our project the best chance of success. Sonardyne has learned a huge amount about their aquaculture operations and how our technology can be used to help in a number of impactful areas.
I hope you found this video useful. If you have any questions about what we've covered today, please get in touch with us at sonardyne.com or through your local Sonardyne office. Don't forget to subscribe to our YouTube channel and like this video to stay up to date with everything from Sonardyne. Thanks for watching.